All right, so welcome. My name is Molly Webb. I am a GIS and data developer on the data services team on the university libraries. Today, we're here for the workshop Data Wrangling, which is part of our series of workshops on using data for graduate students. We have a couple more workshops in this series coming up, including data visualization happening next Thursday, and then a few more in the coming weeks. So go ahead and check out the library's website for other dates, topics, and to sign up. This workshop and all of the other workshops in this series are being recorded and they're going to be posted to the Data Services YouTube channel. So keep an eye out on your email. I'll let you know when the recording is available. So the folks on my team and also at Becker, we're here to assist you manage your way through the data lifecycle, which runs alongside the research lifecycle. Specific to our session today, we're going to be focusing on this portion of the lifecycle, targeting data wrangling and analysis. So collectively, this is part of the category of data exploration, in that we are going to be investigating different data sources and preparing our data for analysis. I'm referring to the word wrangling here in this workshop, but it's also referred to as data cleaning, data scrubbing, and any number of different names for doing the same thing. All of it is to prepare for the next step in the research lifecycle, which is often analysis. And you may even have to go back and forth between these steps several times. Analysis can mean many different things, and that's going to be unique to your own field of study. So we're not going to quite get there today. We're going to talk about how we can prepare your data for analysis. So in this workshop, we're going to be focused on data that can be read as text by a computer, although data doesn't necessarily need to be on a computer. Really, data is information that can be stored in a structured or standardized format. But most of the time when we are wrangling our data, it's on the computer. And also, it might not be necessarily in a format that is nice to look at. So, for example, the table on the left would be really nice for a glossy report or some kind of publication, but the separate tables and the formatting and the special characters in the cells could cause problems if you wanted to actually analyze these values. Typically, we want to strip any formatting as a first step to preparing your data for cleaning. So we can see that our little computer friend here in the lower right-hand corner really loves this table on the right, which has no formatting. Same with data that isn't necessarily in a table, maybe big chunks of text, entire books, or even entire collections of books. The layout on the left has a nice presentation, but there's a lot of formatting, extra elements like these bullet points, like the image, and these might get in the way when it's time to actually do analysis of our textual data. So the computer, our computer friend, likes something more along the lines of this text on the right. All of the formatting has been stripped away, leaving just the text for the computer to read. Since we know that we're going to get rid of any formatting, this also means that we don't want the meaning of our data to get lost when the formatting goes away. So for example, using color to indicate a particular value or state of the data. This table shows a list of people with color shading to represent whether an employee is a current employee or a former employee. If we strip the color shading, then the information about the employee status would be lost. So instead, what we want to do is make sure all of the information is represented as an actual value. So here we've transferred the values for green and red to a new column called status. And now it's easier for us to sort and filter based on current and former employees. Same strategy for formatting like strike through. So strike throughs are also likely not to be recognized by the computer. So we'll do the same thing. We would translate all of our strike throughs into a new column of values and call that column status to represent the status of each employee. Another tip regarding formatting. So, primarily when working with applications like Excel or Apple Numbers or Google Sheets, um, I recommend avoiding the merging and splitting of cells. So, again, this can be fine if we're creating a table that needs to look nice for some presentation, but for analysis, we want all of these values to have their own cell. So, this column on the left has merged values based on the location of a particular employee. And what we can do here is we can we can keep the location column, but break up the cells so we have one cell per record, and we're repeating these values across the different employees. Also in this table, we have a split cell for an employee that has multiple roles. So again, we would essentially break those out and include a duplicate record for this employee to cover their additional roles. So one thing we need to know though is that this actually changes the nature of our table slightly in that now each record represents a role instead of each record representing a person, which leads me to another point. So ideally, before you start the cleaning process, or at least at some point as you go through it, you need to have an idea of what you want your data table to look like when you're done, or what you want your data to look like when you're done. So again, this is going to depend on the type of analysis strategy that you're taking, or even the application that you're going to use for analysis might have a specific format that it wants the data to come in. And so some things to think about would be, um, what do you want that final table to look at? So this sample table here includes results from analyzed soil samples from different sites. So my question, do you want each record in your table to be a unique site? That is how this table is set up. It includes the site ID as well as the location and then the values from that soil sample. But what if your study requires gathering multiple samples from each site? So you might want to have a table that looks closer to what's shown now, where every record is a sample taken and they each have their own sample ID. And then each record also includes the site ID, the date, who it was taken by, the location, and so on and so forth. A few more examples of this across different disciplines. So, do you need a table where every record is a patient or every record is a clinical visit by a patient? Do you want a table that is a list of cases by case number, or do you need a table of services received where multiple services could be applied to an individual case? Or do you want a table where all of your records are authors, or do you need a list of publications that can have more than one author? And maybe you might need both of those types of tables. Maybe you might need multiple tables. As a rule of thumb, I like to suggest that when you're creating your data table, go for the smallest unit possible or the most granular level of data, because you can always aggregate or summarize later. This author publication example brings me to another point on data structure, and this is the concept of wide versus tall data. And really, it is as intuitive as it sounds. So wide data is structured to have a higher number of columns, and typically every record has a unique value or a unique ID in its first column. So here we have a sample table where each record is a fictitious author with publication titles listed out in the individual columns. So this is fine for data where you know you're going to have a small finite number of columns, but what if one author has 100 publications? Would you have an additional 100 or more columns in this table to accommodate that information? Maybe, and maybe that's what you want, but I would suggest that another tack you could take with this kind of data is something like this now, which is a tall table. So this table has one record per publication and one combination of
Hmm.
author and publication, and it holds a unique ID for each publication and repeats the author ID that could link back to a different table that's just authors. So some applications call for wide data, others call for tall data. It all depends on what you need to keep together in one table. Sometimes you'll need to flip back and forth, and many data wrangling applications have functionality that allow you to do this without a huge amount of effort. Speaking of effort, though, I think we probably all know that getting our data to this place can be really time and labor intensive. So, all the more reason to have an idea of what you want your data to look like before you really get in and start doing that cleaning. So, like I said before, you may have to go through many iterations of your data collection, wrangling, analysis, and then maybe start all over again, too. This is all part of the process. Generally, after collection, we want to get to a state of technically correct data. And then, after some additional cleaning, then we want to have consistent data so we can move on to our analysis. So, what do we mean by technically correct and consistent data? So, technically correct data is data that can be read or analyzed by a computer. So, we get started with our text only, and then we do some cleaning to get it to its technically correct state. Ideally, you want to have each observation in its own row, each variable in its own column. We want to make sure that the computer recognizes the correct data types and that there are no extraneous symbols or characters that could be misinterpreted or otherwise interfere with the computer reading these values correctly. Another thing to remember is that rows and columns should be independent from one another, meaning that if you switch the order of the columns around or you sort and filter the rows, it's not going to impact the integrity of your data. So once we have our technically correct data, then we may want to do some checks to make sure that our data is consistent and that this data is ready for analysis. We want to make sure that all the values make sense. If not, we need to decide what to do with them. Do we want to exclude values that are way off from the rest, or do we want to include them and maybe specifically call them out as outliers? Do the relationships between the variables make sense? And again, we may have some back and forth here. Once we start analyzing the data, we might figure out that we need to go back and do some fixes and then start our analysis again. So, that brings me to the portion of this workshop that I call the Data Wrangling Platform Buffet. What I'm going to do is I'm going to go through a few different platforms and I'm going to perform some of the common data cleaning tasks that you might do to get started, including reading data in from a file, checking the structure of the data, working with different data types, exploring data values, working with dates, and then finally, we may want to export the data out to another file. I've selected three platforms to demo for you today, and none of them are Excel, Apple Numbers, or Google Sheets. These applications, Excel is really great. They can be handy for taking a quick look at your data. But when you make changes to your data in platforms like Excel, the steps that you take to get your data from its input state to its final state are not recorded or documented, and it may be difficult to remember later and hard to reproduce it if you have to do these steps again. So when we're doing our research, documentation and reproducibility, they're really important. And so we want to make sure that we can track the steps that we take to get our data to its final state. So the first platform we're going to take a look at is OpenRefine, which is available for free download at this link here, openrefine.org. It's also cross-platform, so you can run it on Windows or Mac. The platform runs through a web browser, but the web browser is actually not connected to the internet. So your data stays local to your machine, which is good if you need to make sure that you keep your data as secure as possible. It can read a lot of different file types, and combining files is really easy in OpenRefine. Also, it doesn't alter the original data, and your steps that you took to do your cleaning are recorded. So very helpful. Mhm. Okay. The other two platforms are code-based, but they are fairly intuitive. So you don't need to know a whole lot of code to get pretty far with your data cleaning. So the first platform, or the first code-based platform we're going to look at is Pandas, which is a Python library. You can run it through the command line. You can run it through an integrated development environment, or IDE, or a notebook like Jupyter Notebooks or Google Colab Notebook, which is what we're going to be using for our demo today. And that is a web-based notebook platform. Again, Pandas can read in a variety of different data sources. It's not going to alter that original data. It's going to read it in and hold it in memory. And then you can export your clean data when you're done. Naturally, code is kind of self-documenting because you run the code line by line, you know what each is happening, and then you can also add additional comments to your code. In the notebook environment, you can add not only comments, but then additional textual information to either tell your future self or your collaborators what you did to clean the data. And then the second code-based platform I'm going to use is RStudio Desktop, which is an IDE for R created by the company that used to be called RStudio, but now it's called Posset. And I'm going to be actually demoing the cloud version of this called Posset Cloud. And so that's a workspace where, again, it holds all of the code and the data in memory. So you're not altering that original data, and then you can write out or export the cleaned data when you're done. Okay, so my main goal during our workshop today is to get through the OpenRefine portion, which I think we'll have plenty of time to do. But since it's a GUI, or a graphical user interface, I'm going to be doing pointing and clicking on buttons and working interactively. So I've provided the link to the Google Colab Notebook and the Posset Cloud workspace, should we not have enough time to get those through. But okay, so like I said, in the presentation, this slide has the links to the workspaces. The CSV file that we're going to be using is also saved to that Google workspace, so you can pull it down. But all of these platforms, we're going to be accessing the CSV file directly from Google Drive. And then when the time comes, here's the link to the Google Colab Notebook and to the Posset Cloud workspace. Okay, great. So I'm going to get out of my presentation, and now I'm going to move over to my web browser where I have OpenRefine open already. So OpenRefine, it's a fairly lightweight application. It doesn't take a whole lot of time to download. And then when you actually start Open Refine, it's going to open up your default web browser and it's going to run here in the web browser. I can see here this URL is actually a local path on my machine. Okay, so when Open Refine opens up, the first thing it's going to ask you to do is going to be to choose some files. We can either bring in some files from our computer, or we can also access directly via URL. So I'm going to go back to my presentation and I'm going to copy that link to the CSV file. So I can drop that here in the web addresses URL box here. And let me turn on my cursor so you can see a little bit better of where my mouse is. So this is a download URL for the document on Google Drive. It's different than the share URL for a Google Drive document. But what is consistent between those two URLs is this unique ID for this particular item. This is not going to work if you use the share URL for a Google document. You need to make sure you use the download URL. All right, so after I put the download URL in the text box, I'll hit next. It's going to go through and kind of parse out the data and show us a little preview here before we go into the actual application to start our cleaning work. It gives us a few options here. It lets us choose what format the data is coming in. It lets us decide if we're going to store the blank rows and blank cells, or are we just going to get rid of them. I'm going to accept all of the defaults for right now, and then give my project a descriptive name. Just taking a quick look at the data that we have coming in, we've got some records here that look like we have a unique identifier or case number, a city, state, zip, an income value, and then a date value. So imagine that these are results for, say, some kind of income survey that was sent out or that you gave to a bunch of users and then they returned some values. And we tried to catch a bunch of different data types here so we would have something to work with for our workshop. So I'm going to call this project, I'll just call that survey sample. And then I will hit create project. Okay, so it's brought the data in and we're working in our main window here. We can choose how many records we want to show at once. It tells us that this data set does have 1,068 rows. So I'll go ahead and just have it show us 100 records at once, just so we can kind of get an idea of what we're looking at here. All of the actions we're going to take are going to come from these little column drop downs here. So the first thing we're going to take a look at is see what data type Open Refine has recognized these columns as. And so to do this, I'm just going to place my cursor in this top cell right here and click edit. And this tells us that this particular cell and really all of the cells in this column are being recognized as text. If I look at each one of these, we're also going to see that really all of them are coming in as text values. Even this income column here is coming in as text. So we know we're going to need to do some work on that because we may want to actually analyze income as a numeric value. So we're going to have to take care of that. Okay, so we can either go in here and we can make some changes. So what we're going to do is we're going to apply some transforms to this income column here. So in order to do that, again, we're going to go back to this drop down, which is kind of the starting place for all of our actions in Open Refine, like I said. So we go to income and we're going to go to edit and then common transforms. This is going to have a lot of the typical, at our fingertips actions that we're going to use. So I'm going to say, okay, common transforms. I want to transform this to a number. And so I'll go ahead and do that. It's going to give me a little note here that it transformed 1,062 cells as income. We have 168 cells, so there were some cells that didn't get caught there. Let's see if we can figure out what's happening. So I'm going to click on the drop down again, and this time I'm going to go to facet and then numeric facet. So what this does is it gives us kind of this histogram of all the values coming in, and it shows us that 1,062 values coming in were numeric. 6 of them were non-numeric. So really easily, we can just uncheck that box next to numeric, and it only shows us the values that are non-numeric since this box is still checked. So looking at the income value here, it looks like a lot of these had a value of NA coming in. We have a none, and we also have probably a misplaced value that is St. Louis. So obviously that is not correct. So in Open Refine, if we only have a couple records to edit like this, all we have to do is just go to that edit box. We can delete the value, and then we can say apply to all identical cells. It will automatically go through and remove all of those NAs. We can do the same thing with our none value. We can just get rid of it so it's blank, and then we'll do the same thing to St. Louis. Okay, cool. So now we're showing blank values or essentially no data, which, again, depending on the tool that you're going to use for analysis, you may want like a null, you may want just a complete blank. It's going to depend on kind of where you need to go with this, but this is a good way to kind of clean up all of those values that don't necessarily match with what you need. Okay, so another thing I want to point out now that we've done a couple of steps is if we click on this undo redo link or tab, excuse me, it lists out all of the steps that we've already done. So first we created the project, then next we transformed that column to numbers, we edited some different columns, and then, here we are at this result. So every time we do an action in Open Refine, it's going to record this here. And then we're going to hit extract to export those steps. Judith, go ahead with your question.
I think I missed where you went to transform the data from text to numbers.
Okay, let me repeat that. So what I'm going to do is I'm just going to hit, I'm going to go back to facet filter, and I'm going to hit reset. Okay, so that resets my view over here. So what I did was, and like I said, anytime you're wanting to do anything, start with this drop down here on the column header. Then I went to edit cells and then edit cells and then common transforms. And in the common transforms menu down here, there is the option to transform to a number. So when we brought it in, it was being recognized as text. And then when we did the transform, we said transform to a number. Thumbs up? Okay, cool. Thanks. Okay, so now let's take a look at this St. Louis City column here. So if you have ever worked with any kind of free input, and especially if you're asking people who live in St. Louis to type out the city that they live in, you're probably going to get like 20 different ways of the spelling of the city St. Louis. You might get Saint Louis where Saint is written out. You might get something like ST period space Louis. You may get St. Louis without the period. You may get STL. So lots of different ways to refer to the name of the city that we're in. So what we can do in Open Refine here is we can, let me exit out of that. I'm going to go up to the city column and I am going to go to facet. Now this time, I'm going to choose text facet. So what this does is it goes through and it finds all of the unique values in our city column and lists them out here, as well as the frequency that these values occur in our data set. And then one of the really cool things about Open Refine is this cluster mechanism right here. So I can hit cluster. Then what it does is it goes through and it tries to give a guess at uh, the common values that may really be the same thing. So here we found that it found ST period space Lewis, and then it also found ST space Lewis. 217 rows in ST space Lewis, and then 154 rows for ST space Lewis. So what it's going to ask us to do here is take all of these values and I can say, all right, take anything that occurs that has either of these values, and let's go ahead and make it ST period space Lewis. So I can type in whatever value I want here. I can say merge and recluster, where it goes back and tries to see if it can find any more clusters. So I'll go ahead and do that. You must check some merge. Okay, that's fine. Merge and recluster. Okay, so now it's gone through and combined all of those. It didn't find any more clustering, but there's different options for the clustering method here. So you can kind of experiment and see which methods result in the best cluster detection for you for your data set. I'm going to close that for now. And now let's see where we're at. Okay, so we have ST period space Lewis. We still have some Saint Lewis's here. So what I can do here is I can go to edit and I can say, okay, find everything that's Saint written out Lewis and change that to ST period Lewis. And so that's going to take care of all of those in like 2 clicks, which is really nice. So we can see that all of our St. Louis values here are ST period space Lewis. We can do the same thing with U City. Say we prefer University City written out. So again, we can go to edit and we can say, okay, give me University City for all these. All right, so that looks good. Kirkwood looks good. Okay, so we have one kind of weird outlier here, this Mo. Say I want to take a look at all of the records that are just Mo. If I just click on that link, it's going to automatically filter for this one record that is just a little off. So what I can do here is go back to my manual method that we did at the very beginning. And I'm assuming that this is just kind of a the data was entered in the wrong place. This is the same record that had St. Louis for the income value. So I'm going to go ahead and edit the city for this to be St. Louis. We'll apply that. Okay. Mo looks fine. And then our income looks fine. Okay. So now if I click that again, the city facet updates. Now we've got a nice, neat, clean city column that has all consistent values in it, and we're ready to move on. Okay. So finally, here in Open Refine, we're going to take a look at our date field. So if you're working with data at all and you've had to work with dates and times, I'm sure you understand how frustrating it can be, because it seems like every application recognizes dates differently or wants a different format. And so, it can be kind of frustrating to get dates to behave themselves. So let's see what happens happens when we try to do another one of those common transforms in on this column. So I'm going to click on the column drop down. I'm going to go to edit cells, and then I'm going to go to common transforms, and this time we'll try to date. Okay. So it updates us here that it was able to do that transform on 1,066 cells, which means that there's a couple of cells that didn't quite make it into that format. Okay, so let's see if we can narrow down what our problematic dates are. I'm going to go to the drop down again. I'm going to go to facet, and this time I'm going to go to timeline facet. Okay, so again, it's giving us this histogram here of the number of records that are occurring at which date. And it looks like there are, most of them are coming in fine as dates. But if I want to look at the two non-time dates that came in, I can uncheck this box and it shows us these two records that had weird dates that couldn't be transformed. All right, so we've got this date, which was not in the same format as the others. And then we've got this date, which is actually an incorrect date. There is no February 33rd. So I'm just going to go in and kind of manually update these. We'll go ahead and set that to July 1st. Okay, and then we'll update this one. Let's just assume that that one's supposed to be February 3rd. Okay. All right. So again, now if I go through and I go to edit cells, common transforms to date, it went ahead and applied the transform to those two cells. And so now all of those records are showing up as normal dates. Okay, get rid of that so we can see all of our records now. Okay, so our data is now much cleaner than it was when it came in, and we're ready to export it to go into whatever application or however else we're going to analyze it. So to export, all you have to do is go up to the export button here at the upper right-hand corner, export, and then there's a variety of different file formats that it can export into. I'll just choose comma separated values, and then that will let me export a, we'll call it the edited or clean version of this data set. So now let's move on to our Python notebook. Okay, so I have that open in another tab right here. When you arrive at the Google Drive location, you'll see that there's a folder with the workshop data. Here's a copy of the PDF or the presentation that I was showing earlier. And then also here is that notebook. So you just click on the link to go to the notebook, and it's going to open up this Google Colab window right here. So if you're not familiar with Python notebooks or Google Colab, it's a really handy web-based, Python environment. You do have a fairly solid RAM and file space available in your Google Colab notebook, so it can do at least some casual computing, if not heavy computing. Along the right side here, we've got a table of contents that are going to show us the different sections we're going to work through. And then as we create variables, all of our variables are going to show up in this variables window. For this workshop, we're going to be bringing in our table from Google Drive again. But if you have local files installed on your machine, you can go to the files section here and you can upload files so that you can still access that data in your notebook. But for purposes of this workshop, we're going to kind of keep it easy and we're going to use that Google Drive download link to read in our files. All right, so notebooks are going to have these text chunks like this that can give explanation to what the code is doing. And then we're also going to have the actual code chunks that we're running individually. So here's my contact information should you want to reach out to me. And then in this section here, it just explains that we're going to be bringing in the file using that Google Drive URL. I do want to point out that since this is all within the Google environment, you can access files from your own Google Drive too. So at the very end, I include a couple of lines of code there, should you want to explore that option and connect directly to your files on Google Drive, which can be pretty handy. Next, we're going to take a look at the code that sets up our script, import some libraries, and set some local variables. So the two libraries that we're going to use to start off with are the OS library, which gives us access to some of the components of our computer or the computer running this code behind the scenes. And then we're also going to import the pandas library here. Typically, if you're running this in Python just locally on your machine, you will need to actually install the Pandas library. But in the Google Colab environment, Pandas is already installed, so we don't have to go through the install process. We do, however, need to import Pandas into our script so we can use it. To run the code, all we have to do is click on the little play button here. It's going to run for a couple seconds, and then this green check mark indicates that this code ran successfully without any errors. The next line of code is just inputting a string that represents this download URL for that survey data CSV that we were just looking at. So we're going to look at the same data here and essentially perform the same steps. So I'm going to run this. Okay. The next thing we're going to do is we're actually going to read the data in. So using the read CSV function in Pandas, we're passing in the URL to the Google Drive document. It's going to read it in, and then it's going to be in a data frame format, which is essentially an in-memory table being held here in our Python notebook. So let's read that in. And then the next couple of lines of code are going to give us some information about this data frame. So data.shape is going to be a tuple with the number of rows and columns in our data frame. So we know from our Open Refine work that we had 1,068 columns or excuse me, 1,068 records with 6 columns. That's showing us the same thing right there. If we want to, we can use the head function to show us just the first 5 records of our data set so we can kind of see what the data looks like, what the column names are. If we use the count function here, it gives us the number of non-null rows for each column. So we can see that most of the columns do have values in all of the records, but the income column does have a few null records in that since it has 1,064 coming out there. We're going to use the data describe function that's going to give us some information about the values in each column. Now, it looks like some of the columns coming in that are really textual values are being recognized as numbers. So for example, we have zip coming in and it's giving us a mean, standard deviation, minimum value for zip code, but zip codes are actually not numbers, they're categories. And so really, we're going to need to do some work to update our zip code column to a textual column. If we use the include and then pass in a list of the different data types we're looking for, the describe function will give us the results for only those data types. So if we pass in the object data type, which is kind of like a mixed case or a mixed data type, it might be numbers, it might also be text all in the same column. This just gives us information about those columns that Pandas is recognizing as the object data type. So similar to what we did with Open Refine, we want to convert our zip codes to strings. We want to convert our income values to numeric values, and we want to make sure that our city names are valid and consistent. All right, so let's use the dtypes property of the data frame, and let's take a look at how Python is recognizing those data types. So case number and zip code, it's recognizing as integers here, and then all of the other ones it's recognizing as object data types. So what we want to do here is we're going to take the zip code column and we're going to replace the values, the current values in the zip code column with values that we have converted to a string using the as type function here. So when we run that line of code and we take a look at our data types again, we can see that it's converted the zip code column to a string object type. Okay, so we're doing great so far. Let's take a look at the income column now. We know that income was coming in as an object or a mixed data type, but we really do need them to be numeric for our analysis that we're going to do. So the first thing I want to do is I want to look at all of the unique values for income coming in, and I'm going to do that with a combination of running the unique function within pandas and then also putting that into a for loop. So we're going to get all of those unique values, we're going to loop through them, and then this is just going to print those out. So when we run that code, we're going to get a long line of values here. And specifically, what I wanted to point out is that that one record that's coming in with St. Louis for the value, and then we also have several records that have none. All right, so let's use that same method that we did for the zip code, the as type method right here, and let's see if we can convert income to an integer value using as type. All right, so I run that code, and as expected, we actually get an error right here. So we need to try something different to try to convert all of these values. I'm going to next try the toNumeric function that's part of pandas. And this time I'm going to use toNumeric and pass in the income column value to see if that will work. Let's run that. Okay, again, it didn't work because it's saying we almost got there, but in line 1058, we have a value of St. Louis, and Pandas is saying, I don't know how to convert that to a number, so I'm just going to throw an error at you. Okay, well, let's see again if we can get around that. So the toNumeric function actually has an additional parameter that you can set called errors, which instructs Python, what do you do with any errors? So if we set errors to coarse, then that means that any value that comes in and throws an error is just going to be changed to null. And that's fine. That's actually what we want. So we're going to go ahead and run that. That ran without any errors. That's good. And so now if we print out all those unique values again, we can see that they're coming in as numbers now. We can see the dot and then the decimal place coming in. So that's a good sign. And if we scrolled through all of these values, we would see that we did have some null values or some nan or not a number values coming in. Okay. So let's keep on going here and see how much we can get through before our time is up. All right, so next we need to go and look at our cities again. So we know our cities were a little bit of a mess. We had lots of different values coming in for St. Louis. So let's take a look at all of the unique values coming in for city using that unique function. All right, so here is a list with all of our unique values for the city. Okay, so we'll do universities for University City first. And I just wanted to show this quick example of how you can create a brand new column in your data frame. So right now we don't have a column called country, but this code here creates a new column called country and then just inputs every single record will have the value of USA. So just a quick example of creating a new column. If we look at the first few rows of this data frame, we'll see we have that new column there. Okay, so the next thing we're going to do is we're going to use that new column creation method that we just learned, and then we're going to combine that with the replace method that is attached to string data types in Python. So the replace method wants two parameters. It wants to know what string are you going to replace? And then it also wants to know what are you going to replace that string with. So in this case, what we're doing is we're creating a new column called city corrected. What we're doing is we're looking at all of the values coming in for city, and we're calling the replace function on them. We're looking for all of the values that are U space city, and then we're going to replace them with university city written out. So let's run that code. Let's take a look at our unique values again. And then we can see now the whole U city option is gone, and we only have university city. All right. We could also take a look at this by just pulling out all the records where the city equals U city, and then this gives us a data frame of only those records where city is U city. So in this notebook, I wanted to just give you some different code snippets that you could maybe reuse for common you know, common actions. And a lot of times subsetting records is something that we want to do often. So that's why I wanted to show that to you here. So we also know that we have that one record that had a value of Mo for the city. So we can pull that out in a subset, just looking at this one particular record here. And so we can see we've already corrected that income value, but we're still showing city as Mo. So what we can do here is we can again use that replace function, find all of the records where city is Mo, and then replace that with St. Louis. Now, in this case, instead of creating a new column, what we're going to do is specify the in place parameter as true. And so that means that it's going to not create a new column of information. It's going to just replace that value right in the city column, right where it exists. So let's run that. It ran successfully. So now we run that code to show this specific record again. This time we're just going to call it by case number because we know it's case 1059. So we run that. And there we go. City now equals St. Louis. We can use that in place parameter again to replace the value, the uCity values instead of creating a new column like we did before. So let's go ahead and run that. And then we look at the unique records, and there we go. We have University City and Mo is gone. Okay, so the final thing I'm going to leave you with just in these last couple minutes is the concept of regular expressions. So, regular expressions is kind of like a programming language in itself, but really what it helps you do is find more complex patterns. So, using the replace function before, we were just looking at really simple string snippets, but sometimes you might have more complex strings that you're looking to find, and then more complex things that you want to replace them with. So I wanted to just give you a couple of links here to resources where you can explore regex a little bit more, and then give you an example to work from. So regex is a library that gets installed with base Python, but we do have to import it into our script by calling import RE to be able to use regular expressions. The next thing we have to do is we have to determine which pattern we're going to look for. And so we're going to do this in this string right here. What this is saying is find all of the instances of Lewis written out. And then this part of the string here is saying anything that's at the beginning of that same string and it has any characters in it whatsoever. When you find this pattern, I want you to replace it with st period Lewis. So first, we have to set this pattern to a regex pattern by using the compile function right here. So that's saved now as stl pattern. Then we can go back to that replace method that we knew before, and we can say we want to replace any instances of that pattern that we just created. What I want to replace it with is the value of ST period space Lewis. The regex equals true, meaning yes, we're using regex for this. And then we're going to also use in place equals true to say just change the data right in place. Don't create a new column or anything like that. Okay, so we did that. Let's take a look at those values. And now we have these three unique values coming in. Everything looks nice and neat, and we're ready to move on to the next thing. Unfortunately for us, though, today we're out of time, but you do have these notebooks that you can work with, that you can work through at your own pace. You also have my email address, so feel free to reach out with any questions either about the workshop content or anything that you might be working through in your own research. Always happy to help. I really appreciate you attending the workshop today. And if you have any questions, I can definitely stick around for a few minutes. Else, I'll let you know when the recording's ready. Thank you so much.